Welcome and thank you for joining this webinar, The Architecture of Autonomy, Distributed Artificial Intelligence as a Native Capability of Future Wireless Networks, prepared by the Alpert Research Team. Wireless networks are entering an era where complexity, scale, and performance demands exceed what centralized control can manage. Distributed artificial intelligence enables networks to sense, learn, and act autonomously across devices, edges, and cores.
Let's define this properly, because distributed AI, what does it actually mean in a wireless context?
It's much more about the behavior than the specific hardware. The Alpert report has a good, clean definition. It calls DI a system where autonomous computational nodes, let's just call them agents, collaborate to solve a problem. In a traditional centralized system, the nodes are effectively slaves. They're dumb terminals. They just do what the master server tells them to do. In a DAI system, the nodes have a degree of autonomy.
They can make local decisions on their own.
But they also talk to each other to solve bigger system-wide problems.
So instead of a general in a bunker barking orders at soldiers, it's more like a squad of commandos who all know the mission and have to figure out how to execute it on the fly, on the ground.
And the key contrast is with that centralized AI model.
Right. Centralized AI is a monolithic brain in a jar. DI is a team. It's about local perception, seeing what's happening right in front of you. Local learning, updating your own understanding based on that perception. And then, crucially, coordinated decision-making.
So they don't just do their own thing.
No, that would be chaos. They coordinate with their neighbors, but they generally don't send them all their raw data. They share insights, not secrets.
And for that to work, it relies on 4 key pillars. First, as we said, autonomy. The node doesn't need a constant, stable connection to the mothership to function. It can handle things locally. Second, collaboration. They share knowledge. Third is heterogeneity.
Which just means a bunch of different stuff, right?
Right, but in engineering terms, that's a nightmare. You have a super powerful server trying to collaborate with a tiny battery-powered temperature sensor that has almost no processing power. The system has to make them work together seamlessly. And finally, decentralized control. There is no single point of failure.
Which makes the whole network more resilient. In this DAI world, my house should just keep running because the intelligence is local.
Exactly. It just mirrors the physical reality of the network. The wireless network is already geographically distributed across the entire planet. Why would we insist on centralizing its brain when its body is everywhere? It's an architectural mismatch. DAI is designed to fix that mismatch.
If you want to understand DAI, you have to understand the agent. It's the fundamental unit, the building block.
What is an agent in a wireless network?
In computer science, an agent is a software entity that can perceive its environment and act upon it. But it's not just a simple script. A script is very rigid. If A happens, do B. An agent is much more complex, much more intelligent. The report defines 4 core properties that an entity needs to have to be called an agent.
All right, let's walk through them. The first one is autonomy.
Autonomy means it operates without constant external control. This is the cut the cord test. An autonomous agent keeps making decisions based on what it knows locally. It doesn't need a babysitter. It can function on its own for a period of time.
The second property is reactivity.
This is about speed. It means the agent perceives its specific local environment and responds to changes in real time. So if there's sudden radio interference, a reactive agent in the router changes its frequency immediately.
It doesn't wait to send a report to the cloud and get instructions back.
No, it doesn't wait for a ticket to be processed at headquarters.
Well,
It senses the problem and reacts in microseconds.
third one is proactivity.
Proactivity means the agent isn't just stimulus response. It isn't just see interference, change channel. It actively pursues long-term goals. It has an objective function it's trying to optimize. It's not just reacting to a problem. It's anticipating it and preventing it. It's planning. That's the key difference between reactive and proactive.
So it's predicting the future, essentially.
In a limited statistical sense, yes.
And the fourth and final property is social ability.
This is what makes it a system, and not just a bunch of lonely robots doing their own thing. Social ability means they can communicate with other agents. They use standardized protocols. They can negotiate, they can collaborate, they can delegate tasks.
So they can talk to each other.
They use standards like the A2A agent-to-agent protocol. It's a common language.
Okay, so we have these autonomous, reactive, proactive, social agents. They're the building blocks. And the report puts some real numbers behind this.
The 2025 analysis they cite is very specific. They found that multi-agent systems are delivering between 21 and 35% cost reductions in pilot deployments.
That is a massive number for a telecom operator that's usually operating on razor-thin margins.
And on top of that, 2 to 15 times throughput gains. This is the evidence for that big shift from AI as a workload, just another app running on the network, to AI as the control plane, where the AI is the network manager.
We're running out of time, space, and energy, so we need to spread the thinking out.
Distributed artificial intelligence is central to the evolution of 5G Advanced and 6G, redefining how wireless networks are designed, operated, and trusted in the autonomous era.
It really is the future of the field.
And if you are interested in gaining a deeper understanding of the transformative power of wireless technology, the Alpert Research Team runs webinars where they explore these cutting-edge wireless innovations, their applications, and their implications. We encourage you to click the links below to learn more.
It's well worth your time if this topic is interesting to you.
Thanks for listening. We'll see you next time.